Hello, so in the previous video we talked about the notion of an informal tautology. In this video we're going to learn about formal tautologies, that is tautologies in the formal language, and we're also going to get the truth tables that define the negation and the conjunction symbol. So what are those? Well, you'll find out at the end of this video. So remember, what is the tautology? It's a sentence that is true in every situation, absolutely every situation. There's no situation in which the sentence is false. That's what a tautology is. So we saw that it's not the case both that Bob runs and also doesn't run. That's a tautology. We saw that in every situation in which Bob runs, that sentence is true. And in every situation in which Bob doesn't run, that sentence is also true. And so we saw that this sentence is true no matter what. Now, we could symbolize that English sentence and it would become negation and then parentheses P and not P parentheses, so it's a negation of a conjunction where the conjuncts are a sentence P and the negation of the sentence not P. And this sentence in the formal language is also a tautology, and it's always true. And we can go through very similar reasoning to the reasoning we went through about it's not the case that Bob runs and doesn't run to see that negation P and negation not P is itself a tautology. Okay, so suppose that P is true. That means that not P is false. That means that P and not P is false because one of its parts is false and it's a conjunction. It says they're both true. And that means that the negation of the conjunction is also true. So if P is true, then our whole sentence is true. Now suppose P is false. Well, in that case, P and not P is false again because this time the P conjunct is false. And that means that the whole thing, negation P and not P is true. And so whether or not P is true or P is false, negation P and not P is true, and therefore it's a tautology. Now let's think about what we did. So we divided all of the possible situations that there could ever be into two kinds, the kinds where P is true and the kind where P is false. So every possible way the world could be is represented by this circle, and we can divide them into those in which P is true and those in which P is false. And then what we said is, oh, well, look, our whole sentence, negation of P and negation P, that's true in the situations where P is true. And hey, guess what? Negation of P and negation P is also true in all the situations in which P is false. But hey, those are all the situations. And so negation of P and negation P is true in all the situations. That's the reasoning that we've done. We could represent this in a table. How would we do that? Well, so first suppose that P is true. Well, that means that negation P is false. And that means that P and negation P is false because the right conjunct negation P is false. And that means that the negation of the conjunction is true because the conjunction is false. Okay. Now suppose that P is false. Well, in that case, negation P is true. So is P and negation P true or false? Well, it's false because its left conjunct is false. P and not P has a false conjunct, namely P, on this row of this table. Well, if the conjunction is false, then the negation of the conjunction is true. The conjunction is false, so the negation of the conjunction is true. So what we've done is we've represented this reasoning in a table that we did before. Now we have it in a table where on each row of the table we're looking and seeing, okay, what's P's truth value? And then given P's truth value, what does that tell us about the truth value of these bigger sentences? And so on the first row we have any situation in which P is true. Here are going to be the truth values for these other sentences. Second row, any situation in which P is false. Here are the truth value for all of those sentences. So on each row we find out the truth value of a bunch of sentences given the truth value, in this case, just of P. And hey, negation P and not P, that's the last column. We look at that column, and it turns out that on every row, that sentence is true, and so that sentence is true no matter what. So this is an efficient survey. It's a way of surveying all of the possible situations there ever could be in two rows. So this was an example of a truth table for a specific sentence. We divided all the situations into two groups, those in which P is true and those in which P is false, and then we figured out whether or not negation P and not P is true in the P is true situations, and we figured out whether or not it was true in the P is false situations, and in fact it's true in both of those kinds of situations, and so it's true in all the situations. So far, our survey this example relied on our sort of intuitions about how negation and conjunction work. Now we're going to define the negation and the conjunction. We're going to talk about the conditional in the next module because the conditional has a slightly strange truth table that's worth its own focus, and I want to explain how truth tables in general work, so we'll see how they work with negation and conjunction, and then we'll add in the conditional in the next module because it's its own thing that's worth looking at separately. Okay, so we're going to explicitly say what these symbols mean. So far, we've characterized these symbols by how you can use them. And that maybe is one way of thinking about understanding what they mean. But now we're going to say in a very explicit way, here's what they mean by thinking about how sentences containing them become true or false. So let's look at a truth table that defines negation. So this is going to say for any sentence box whatsoever, when is not box true? So for any sentence you like, what we're going to do is we're going to tell you when is the negation of that sentence true and when is it false. And we do that by saying, okay, well, when box has a certain truth value, what does not box have? So if box is true, then negation. So we look at the two situations, the situation where box is true and the situation where box is false. Those are all the situations there are. In the situation where box is true, not box is false. In the situation where box is false, not box is true. And that actually tells us what negation means. It tells us that negation just reverses the truth value of the unnegated sentence. So any sentence you have, you can form the negation, and the negation of the sentence has the opposite truth value as the sentence itself, and that's all that negation means. It just says I have this kind of truth value, namely the opposite of the truth value of the sentence that you hooked me up to. And that's what negation means. This isn't a table for any specific sentence, right? It's a very generic table because it says for any sentence whatsoever, here's how the truth value of the negation of that sentence would go. Okay, so we're going to say something similar for the truth table defining conjunction. We're going to say, but this time for any sentences, box and circle, well, when is box and circle true? When is box and circle false? And so we're going to look at the truth values of both components of the truth value for box and the truth value for circle. So suppose that both box and circle are true, then the whole conjunction is true. It says box and circle, and if we look, yes, box and circle are both true. What about if box is true and circle is false? Then the conjunction is false because the conjunction says they're both true, and they aren't both true, so the conjunction is false. What about if box is true and box is false and circle is true? Same thing, the whole thing is false because it says they're both true and they aren't. And finally, if they're both false, then of course the conjunction is false. So the conjunction has a pretty straightforward truth value. It's true when they're both true, and it's false when both of its components are true, and it's false when either one or both of its components is false. Okay. So if we put those two together, then we can see this table one table contains all the information we had on the previous two. It tells us when is box and circle true and when is box and circle false, and it tells us when negation box is true and when negation box is false. So there it is. That gives us all of the sentences. It tells us it tells us what box and circle mean, and so that's how we can calculate what box and circle's truth values are, or what negation box's truth values are. It tells us how the conjunction works, how the negation works, what they mean. So now what? So we had an example of a truth table for P and not P, and we've had truth table definitions for negation and conjunction. So what about the truth table definition of the conditional? And how do we find out whether other sentences are tautologies? So as I said, we're going to talk about the conditional in the next module because it has a funny truth table. We're going to talk about whether or not other sentences are tautologies, how to do that in general in the next video. So there's going to be another video showing you how to do that just in general, and then there will also be a video showing you how to use the truth table module.